All right, this is the video guide for the limiting reactant worksheet. So you'll notice here what we're trying to solve. We want to know the limiting reactant, excess reactant, the amount of excess reactant left over, and the grams of iron that are actually produced. So let's take a look at this. First thing we have to do, we have to balance this. When you end up balancing it, you end up with a 3 here. The 2 goes in front of the iron. And let's see, a 3 goes in front of the carbon dioxide. So 1, 3, 2, 3 are the coefficients. Okay, so let's assume manufacturer has 180 grams of iron 3 oxide and 110 grams of carbon monoxide. So we need to do part D first. How many grams of iron? Since this is a mass-to-mass stoich problem, it's going to have 3 steps. So let's start out with the first one. 180 grams of iron 3 oxide. First thing we have to do is change these grams into moles using molar mass. 1 mole of iron 3 oxide weighs 159.7 grams. Iron 3 oxide, grams cancel. I now know moles. Now that I know moles, I can do my mole ratio. Well, according to the balanced formula, for every 1, I get 2. So for every 1 mole iron 3 oxide, there are 2 moles of iron. Moles cancel. Now I know moles of iron, but I don't want moles. I want grams. Remember, when you're doing molar mass, it's always 1 mole. So for every 1 mole of iron, it weighs 55.85 grams of iron. Moles cancel, so I'm going to take 180 times 2 times 55 divided by 159. It comes out as 125.898. Okay, there's only going to be 2 sig figs because 180 only has 2. So you're going to round that up to 130 grams of iron. Is that my answer? Well, I don't know. It might be, but we can't tell yet. We have to do the other portion. Okay, 110 grams of carbon monoxide. Notice this one has a few more sig figs, but that's okay. That happens sometimes. 110 grams of carbon monoxide. We're going to do the same conversion, converting it to iron. So I'm going to start out with what I know. I need to know the molar mass because I need to get my mole ratio. So 1 mole of carbon monoxide weighs 28.01 grams. Grams of carbon monoxide cancel. I now know moles. Now that I know moles, I can do my mole ratio. For every 3, there are 2. So I'm going to say, okay, 3 moles of carbon monoxide, 2 moles of iron. Okay, and then I need to find the mass of that. So once again, 1 mole of iron still weighs 55.85 grams of iron. Moles cancel. I'm ready to solve. 110 times 2 times 55 divided by 28 divided by 3. When you do so, and notice you're going to have 4 sig figs in this answer because your measurement has 4. 146.2 grams of iron. So how many can you produce? Can you produce 142 or 130? It's the smaller amount, 130. Okay, so what's your limiting reactant? It's going to be the iron 3 oxide. So limiting reactant, Fe2O3, that's part A. And then part B asks for what was your excess. That's the other one, carbon monoxide. Okay, so there's answers to parts A and B. Part C, it wants to know how many grams of the limiting, or excuse me, of the excess are remaining. What I would do if I were you, I would take this initial amount of the limiting, I would convert it to the other thing, and then subtract from the initial amount, the 110. So let's do that. Okay, so I started out with the limiting we said was 180 grams of iron 3 oxide. Okay, molar mass. Every 1 mole of iron 3 oxide weighs 159.7 grams. Grams cancel. Now I'm ready for my mole ratio. According to that balanced formula, for every 1 mole of iron 3 oxide, there are 3 moles of carbon monoxide. Moles cancel. I now know moles of carbon monoxide. Then all I have to do is its molar mass. Every mole of carbon monoxide weighs 28.01. We already calculated that. Moles cancel. I'm ready to solve, so it's going to be 180 times 3 times 28 divided by 159. When you do so, you end up with, what is it, like 94.7, which we have to round up to 95 kilograms. Okay, because of the 2 sig figs, or not kilograms, grams, I'm sorry. 95 grams. Okay, and we know that we started with 110 grams, but it only reacted with 95 grams. Okay, when you do that subtraction, it ends up being 15 grams. Okay, and this is of carbon monoxide in excess. Okay, you cannot say 95 or 15.0 because 95 was only accurate to the ones place, so your measurement can only go to that. So 15 grams of carbon monoxide left over. Okay, let's do the next one. So ammonia is used as a fertilizer. To manufacture ammonia, nitrogen is combined with hydrogen in the following synthesis reaction. To balance this guy, we're going to put 3 here and a 2 here. Okay. Assume we have 92.7 grams of nitrogen and 265.8 grams of hydrogen. So we're going to do the same thing. Limiting reactant excess, how much excess remains, the amount of our grams of ammonia that are produced. So once again, we're going to do the same thing. Start with what we know, 97.2 grams of nitrogen. Notice nitrogen is diatomic, so it has to be N2. Molar mass, 1 mole of N2 does not weigh 14. It's 28.02 because it is diatomic. Nitrogen goes away. Now I want to do my mole ratio. For every 1, I get 2. So for every mole of nitrogen, there are 2 moles of ammonia that are produced. Moles of nitrogen cancel. Now I need to know its molar mass. 1 mole of ammonia weighs 17.04 grams of ammonia. Moles cancel. I'm ready to solve. If I multiply 92 times 2 times 17 divided by 28, I'm going to get 113 grams of ammonia with sig figs. Okay, is that my answer? I don't know. We have to do the other part. 265. 265.8 grams of hydrogen. Notice hydrogen is also diatomic. Brinkelhoff, right? So it's H2. Same deal. Molar mass, 1 mole of hydrogen weighs 2.02 grams. Grams go away. Now I'm ready for my mole ratio. According to my balance formula, for every 3 I get 2. So 3 moles of H2 is 2 moles of ammonia. Moles of hydrogen cancel. Now I need to do molar mass. 1 mole of ammonia still weighs 17.04 grams. Moles cancel. 265 times 2 times 17 divided by 2 divided by 3. When you do so, you get 1,495 grams of ammonia. So yeah, you can produce 113. Okay, so that tells me my limiting reactant then is nitrogen, the one I run out of. My excess reactant is hydrogen, the one that I have excess of. So that's my answers for parts A and B. Now for part C, I want to know how much excess remains. I'm going to start with the initial amount of the limiting reactant. I'm going to convert it to the other thing, subtract from this number. Okay. So just like before, start out with the limiting. We said 92.7 grams of nitrogen. Okay. And molar mass, 1 mole of nitrogen is 28.02 grams of nitrogen. Grams of nitrogen cancel. I now know moles. I'm going to do my mole ratio. According to the balanced formula, for every 1 mole of nitrogen, there are 3 moles of hydrogen that react with it. Then all I have to do is the molar mass. Every mole of hydrogen weighs 2.02 grams. of hydrogen. Moles cancel. 92 times 3 times 2 divided by 28. This ends up being 20.0 grams of hydrogen. That's the amount that reacts. Okay, 3 sig figs. But notice we started out with 265.8 grams of hydrogen, but we only reacted 20 grams. So that tells me that the amount that is excess, if I subtract those, is 245.8 grams of hydrogen in excess. That is the answer for part C. Okay, last one. Accidentally, a small child swallowed 25 grams of barium nitrate as an antidote. 25 grams of sodium sulfate is given. Assume the maximum amount of each of the product is produced. We need to balance this equation first. You're going to find to balance it. All you need to do is put a 2 in front of the sodium nitrate. So once again, we want to know what's limiting, what's excess, how much excess remains, how much of each product is produced. So, or instead of each product, let's just do one of them. Let's do sodium nitrate. That'll be fine. Okay. Let's see. If you understand that, you're golden. So 25 grams of barium nitrate, we said. Okay, and we're going to convert that to, let's say, the sodium sulfate. Okay, so for 1 mole of barium nitrate, if I add those up, 261.35 grams of barium nitrate. Okay, now I need to do my mole ratio. Well, according to the balance formula, for every 1 mole of barium nitrate, there are 2 moles of sodium nitrate. Moles of barium nitrate go away. Now I need to know the molar mass. And remember, when it's moles and grams, it's 1 mole. So for every 1 mole of sodium sulfate, it weighs 142.04. No. I'm sorry. What am I doing here? That's the wrong one. If I add up sodium and nitrate, it should be 85. There we go. That should be 85 grams. Sodium nitrate. That's not it. I apologize. I'm pretty sure it's 85. Okay, so I'm going to take 25 times 2 times 85 divided by 261. When I do so, I get 16.3 grams of sodium nitrate. Okay. Well, I need to do the exact same thing now for the let's see, the sodium sulfate is the other thing, right? Yeah, 25 grams of sodium sulfate. So, start out with 25 grams sodium sulfate. I'm going to do the exact same conversion. So I need to find the moles of sodium sulfate, and its molar mass 142.04 grams. Grams of sodium sulfate go away. Now I need the mole ratio. From the balance formula, for every 1 mole of sodium sulfate, there are 2 moles of sodium nitrate. Now all I need to know is the molar mass. 1 mole of sodium nitrate still weighs 85 grams of sodium nitrate. Moles cancel. 25 times 2 times 85 divided by 142. You get 29.9 grams of sodium nitrate. So how many can you produce? The smaller amount, the 16.3. So my limiting reactant is going to be barium nitrate. thing that runs out first. And then the thing that is in excess is the sodium sulfate. So there's parts A and B. Okay, now I need to know how much is left over. So recall, I'm going to start with the original amount of the limiting. I'm going to convert to the other and subtract from that initial 25 grams. Okay, so for this last part, let's see. Start with a limiting. So we said 25 grams barium nitrate. Oh, you know what I just realized? I didn't observe sig figs, did I? Because I only had, so this answer actually should be just 16 because there was only 2 here. Pardon me. And then this would have been, instead of 29.9, it should have been 30 with a decimal for 2 sig figs. There you go. Forgive me. Okay. So anyway, at least I caught it. Okay, 25 grams of barium nitrate. Let's see. I need to say, okay, every 1 mole of barium nitrate is 261.35 grams of barium nitrate. Grams cancel. I now know moles. Now that I know moles, for every 1 mole of barium nitrate, there is 1 mole of sodium sulfate. Moles cancel. Now that I know the sodium sulfate, I need its molar mass. Every mole of sodium sulfate has a mass of 142.04 grams. Moles cancel. 25 times 142 divided by 261. When you do so, you're going to find that that is 14, I believe. And so initially we said we had 25 minus the 14 that it needed to react. That means we have 11 grams of sodium sulfate in excess. And just so you guys know, with these limiting reactant stoich, they don't have to be all mass to mass. It can be moles to moles, moles to mass, mass to moles, whatever. I just happen to do 3 examples that were all mass to mass, but they don't have to be. But that's basically the process how you do it. So, all right, we'll see you guys.